So, hey guys, today we'll be talking about the intuition behind the formula of permutations and the combination. So, first of all, let's talk about the permutations itself. Okay. Now, in the last lecture, we saw that if I am having m objects and if I want to uh, fill the m places, so m is the objects. Okay. I want to fill the m places, I would say, or the give m objects to the m peoples. Okay, anything is fine. Okay, now in that case, how many choices did we had? We know that the answer for this would be m factorial, because the first person will have m choices. Now if I fix the one person over here, I will be left with m minus one person, and for the second position, I will be having m minus one choices. Now I fix two people, so I am left with m minus two people, and for the third position, I will have m minus two choices, right? So on and so on, and the last will be one, which is nothing but the m factorial. Okay, so I hope we are clear till this. Now let's say I am having m people objects and I want to choose or to fill the k places where order matters. So in textbook you will find the formula like this: m factorial upon m minus k factorial. Okay, now it's fine. That's formula is beautiful. Now let's dig a little bit deeper how it came. Okay, so this is my first position. Second, I will just write position number over here: first position, second position, so up to this is my kth position. Okay, now for the first position, I always know that I will be having the m choices, right? But after fixing the element at the first position, I will be left with the m minus 1 elements. So for the second position, I will be having m minus 1 choices, right? So here we can see that when what will be the generic case for the first position, I had m minus 1 minus 1. This one was here. So what it and sorry, this should be plus 1. Okay, so what this reduced to m. Now at the second position I had m minus 2 plus 1. What this reduced to m minus 1, right? So did you get the logic? If I fix this m and plus 1 term, I need to simply put the position number here to get the number of possible combination. So what would be the case for the kth position? I am having m minus kth position and plus 1 is there, so it would be simply m minus k plus 1. So I can write over here m minus k plus 1, right? So what this will turn into: m into m minus 1, sorry, I need to put brackets, up to m minus k plus 1. Okay, now for the further mathematical simplicity, I can add, multiply and divide by the same terms. This m minus k over here, m minus k over here. Okay, m minus k minus 1 over here. So I will again multiply by m minus 1 k minus 1. So do you are getting this, right? So up to 1. So, and same terms, multiply divide same. So the above term, the or the numerator can be written as m factorial, right? Because we are having multiplication of all the terms till the one, and the below term would be m minus k factorial. Now I understand that this is just the generic formula, but now let me tell you the main intuition how you can feel this formula. Okay, so what I can say is that for the k position, I am giving freedom to, okay, giving freedom to all m elements. Okay, like all the m factorial combinations I am allowing. Okay, so all the m factorial combinations are fine, but out of this m factorial, what I am saying is that, see, for the first m minus for the first k position, it's fine. But for the rest of the position, what may happen is that, say we are having the elements a b c. So this is one of the combinations. Okay, I am, and please remember here I am fixing the first k elements. Okay, and I am talking about the rest of the elements. So the other combination may be, this part is again fixed, and what I am doing is that I am again playing with the backside. I am having b a c at the last. Now you know that even if I keep the first part of the equation same, I can have total 3 factorial, which is nothing but the 6 combinations at the back. But at the same time we know that these are the not the combination we want to include, right? Please, I'm going to say very important lines, so please be focused. Okay, so what we saw, if I fix the initial part and the remaining part of the total m factorial permutation can be a overcount. Why? Because see, here I am keeping the first k position as it is, and the rest of the m minus k position. How many positions are these? These are the total m minus k position. For the sake of example, I have written only 3 elements, but here there are m minus k elements. So there there are m minus k factorial combinations possible regarding to each fixed part of the k position. Okay, so let me tell you again, please don't miss on this what I told you just that. Okay, okay, these are the k elements, I have kept them fixed. These are the my m minus k elements, and what I am doing is that I am performing all the permutation of this m minus k element, and it there will be how many permutations, m minus k factorial, but whereas the first part is still the same. So what I need to do is that those combinations where the first part is same and the rest of m minus k factorial values are changing, I need to count them only once. So what I will do is that I will simply divide by the m minus k factorial. So when I am dividing m factorial by m minus k factorial, what does it implies is that the combinations where the first part were the same and corresponding to which the m minus k position were changing arbitrarily, having all the permutation, are reduced to only one combination. Do you got this? So the next combinations or next combination of the initial k elements will again have m minus k positions, where which will be revolving or the having any arbitrary permutation. But the what division operation did is that it will convert them also to only one, right? Because we are dividing by m minus k factorial, which is as good as we are cancelling out the m minus k factorial permutation corresponding to the fixed first k elements. Okay, now let me tell you one more thing. See, this is 1 2 3 4 5 6 7 8 9 10 11. So whenever how you should visualize the division is that whenever I say 11 by 5, what does it mean? It will give me answer like 2 point something. Okay, 2.5. No, 2.2. Okay, so sorry for that. So what does it mean is that I took the first 5 element. Okay, I was successful to take all of them. I took the next 5 elements. I was successful to take them, but I were not successful to take this, right? So it's been represented with the fraction. Out of 5, I was able to take only one element, which is equivalent to I took only one out of 5. So did you got this? How the division is the how the intuition behind the division works? On the similar lines, what I am saying is that, say you are having the first k elements fixed and the rest of the m minus k elements moving. Do you got this? So what could be happen here is ABC, here BAC, and so on. So all those 3 combinations, oh, sorry, all those 6 combinations, okay, those all will be there. So when I'm dividing by m minus k factorial, what I am doing is that all these combinations where the first part were common, I took them only once, and that's what was our goal is to, right? In the next case, whenever the now this is counted only once, so in the next case we will be having some different combination for the first k elements, corresponding to which we had overcounted the m minus k factorial permutations, and we, by dividing the m minus k factorial, we are counting them only once. So in effect what we are doing is that we are giving freedom to only this part, only these k positions. So that's what the intuition behind the formula is. M factorial means you are giving freedom to all the combine all the elements whatever wherever they want to go, but by dividing the m minus k factorial, what you are saying is that the rest of the combinations which are generating the overcount should be counted only once. And what does the division do? These m minus k factorial combinations would be counted only once, because I just told you na, the division dividing by 5 means it just takes the 5 elements and group them as a one. So divide by m minus k factorial means you are keeping the initial k elements constant and you are grouping the rest of the factorial calculations. Okay, I hope you are clear till this now. Okay, in the next session I will be talking about the intuition behind the combination formula, because I guess this video is getting a little bit longer. Okay, take care of yourself and take care of your time.